is basically the percentage, well, when I ask this, is percentage by mass, okay, of the species. So basically, you're just breaking it down to what percent in the chemical formula it is of each element, or whatever I'm asking. Always assume, unless stated otherwise, it's 1 mole of the compound. Makes your life easier. Okay. The blue marks, so they're
making it hard for me to read.
Is that better? Yeah. That was impeding your learning. Okay, so I'll just read out the steps quickly, but once you do it a couple times, it makes sense. All right. So the first thing, like we do in every pretty much chemistry question, is find the molar mass. Okay. If you don't know the molar mass, figure out the molar mass. All right. Then you're going to calculate the mass of each element in the compound, and you're going to divide the mass of each element by the mass of the compound. You're basically doing a percentage calculation, hence the name percent composition. So what does this look like? What is the percent composition of hydrogen in H2SO4? What's H2SO4? Starts with an H. So that tells you it's a acid. H2SO4 is, somebody say it, sulfuric acid. You're all just looking at me like, okay, sulfuric acid. So we need the molar mass. What does hydrogen weigh? 1. So 2 times 1. Sulfur.
32.1.
How many do we have? 1. 32.1. And oxygen, 16.0. And we have 4 of them, right? Which gives you what?
98.1 grams per mole.
98.1 grams per mole. We always assume we have 1 mole. Okay. Second step. Calculate the mass of each element, or what they're asking you for. So they're asking for hydrogen. So mass of hydrogen in the compound or the formula. So how many hydrogens are in the formula? 2. So what's the mass of hydrogen in the formula? 2.0 grams. Right? 2 times the 1.0 is... So we have 2 grams of hydrogen in a 98.1 gram mass formula. Therefore, purple, the percent, so this is step 3, the percent of hydrogen is how much hydrogen you have, 2.0 grams per mole, divided by, we're assuming 1 mole, so I guess I don't need the moles, but that's okay. The total mass, which is 98.1 grams. And if you want to convert it to a percentage, what do you have to do? You multiply by 100. So if you go 2 divided by 98.1 times 100, you should get about, where's my calculator?
2%.
Let's come up to 2 exactly.
2.03. 2.04.
2.038. And we should have how many sig figs? 2, right? 2 sig figs. So this comes to 2.0%. So 2% of that compound is hydrogen. That's what you do. That's it. Some of the wording might be slightly different. So if I say, what is the percent composition of, what is this compound?
Iron oxide.
Iron oxide.
What are you talking? Which are you talking
Yeah,
about?
I just talking about this one. Of iron oxide. If they just say percent composition and don't list a chemical or an element like this, hydrogen, they're asking for the percent composition of hydrogen. If they just say percent composition, they want the complete breakdown of each element. Okay, so percent. Okay. What's your first step every single time? Molar mass. Number 1, the molar mass. What does iron weigh? 55.8, and we have 2 of them. Plus 3 oxygens, which is 16.0. Add those together, you're going to get, or actually, I'll just do 111.6 plus 48. There's your molar mass of iron oxide. Okay, so percent iron, percent oxygen. How much iron is in this substance, or in 1 mole of this substance? That's the 111.6, right? So we go 111.6 grams divided by the total mass is 159.6 grams times 100. How many sig figs should our answer have? 4. That gives us 69.62, 69.92. 69.92% iron. And the other one is going to be 48, so this should be 48.0 grams divided by 159.6 grams, which should give you 30.1. And this one has 1 sig fig because, or sorry, 1 less sig fig, 3 sig figs total because of the 48.0. Okay. What should these two numbers add to?
100.
They should add to 100, right? Because you only have 2 elements. So if you know you have 30% or 30.1% of this one, you know you have to have 69.9% of that one because they should add to 100. Now, if you did add them and you're using that as a way to check, give yourself a bit of leeway because you're doing some rounding with sig figs and all that kind of stuff. Okay, but in general, it should be close to 100. All right, one more question, and then I'll give you some practice, and then we'll move on to empirical. What is the percentage of water in copper sulfate dot H2O? What type of molecule is this? We did this right at the beginning of the year. This is a hydrate. Okay, so I want to know the percentage of water. What's your first step? Molar mass. Always, always, always. I'll let you calculate it, and then we'll check to see. And then just go through and calculate the actual percentage. Do you know how to photocopy?
Do I know how to? Then you just like put it face down and be like,
I would ask you to do it. People don't like it when I send students to do that, or when students get sent to do that.
why not? Am I not trustworthy?
No, it's just some teachers don't like it. Are we ready for the answer? 1 second.
Let's copy
1 minute.
I mean, you sent me to get a cart, and they let me get a cart.
I know.
I got to use the elevator. Right, good.